In this lesson, we'll be looking at some examples of questions from trial papers that are to do with finding the function given the gradient function, or basically f of x given f dash x. The first example that I have is from Sydney Grammar 2009. The diagram above shows the graph of the gradient function y equals f dash x of the function y equals f of x. For which values of x is the curve y equals f of x increasing? So for this particular question, I should say that y equals f of x is increasing when the gradient is greater than 0. So f dash x is greater than 0. So where on this curve, which is already f dash x, where is this containing f dash x values, okay, which are on the y-axis here, where are they actually positive? It will be right here. Okay, these all contain positive y values, which are f dash x values. So this is between 1 to 3. Okay, so I've written that as an answer here. Part 2, for which values of x is the curve y equals f of x concave up? So concave up means that the second derivative is greater than 0. So if we're finding out the second derivative of a graph, which is already the first derivative, this means that we have to differentiate this function again. When we differentiate this function again, we are actually finding out the gradient of the tangents of any point along this curve. So where is the gradient of this tangent of the f dash x curve greater than 0? That will be basically this portion of the graph. Because if you have a look at the tangents, they are all sloping upwards, which means they are positive. Hence the answer is x less than 2. Part 3. Given f of 0, f of 2, f of 4 equals 0, sketch the curve for y equals f of x for 0 to 4. Okay. Now what we've got to look at first of all is that at this point here, we know that f dash x, or f double dash x actually, equals 0. Okay. And we also see that at these points here, f dash x is equal to 0. Right? So what does this actually mean? When you have an x coordinate, which is at x equals 2, producing f double dash, let's say 2 in this case, is equal to 0, that means there's a point of inflection. Over here and over here, f dash x is equal to 0, which means that on an original function, if I was just to draw this in red, on an original function, we're going to have stationary points, because that's what they mean, right? So, how do these stationary points actually look like? Okay, well, I'm just going to draw some lines here, so we know what's happening at these places. Okay, I'm just going to divide them up. Right? Now, if we have a look at around this point here, I can draw a table out, and we can have a look at x versus f dash x. Okay? So in the middle, I've got the number 1, and f dash x for that is 0, as we can see. Okay, it's on the x-axis. Now, if I was to analyze to the right of that and to the left of that, okay, so maybe just go down by 0.1 and up by 0.1. If I analyze this point, okay, f dash x is a negative value, and to the right of that, f dash x is a positive value. Okay, so what do we know? Okay, just by looking at the gradients of each part here, it will be going down, flat, horizontally, and then going upwards again, which means it's a minimum. So it's going to start off something like this. Okay, now as it goes to the middle part, it's going to create a point of inflection because f double dash is equal to 0. Now over here, we've got another stationary point because f dash x is equal to 0. And if we draw a table out for that and analyze the gradients at that point, so 3, 3.1, 2.9, if we analyze to the left of it, this is a positive f dash x value, and to the right of it, it's a negative f dash x value. So we'll have positive on the left, negative on the right. So it looks like this, which means that it's going to be a maximum here. Okay? Now, there are important details here that tell us what the y values are and x values are. So each of these are x values, okay? And the y value at those x value points are 0. So the first point we'll sketch out is 0, 0. Okay, so we'll put 0, 0 here. And the next one will be 2, 0. So 2, 0 will be somewhere here. And then we also have x equals 4, y equals 0. Let's just put that here. Okay, now just what I said last time, we know that there's going to be a minimum somewhere here, concave up. And also, we can tell because the gradient here is all negative values, okay? Negative y values or negative f dash x values. This means on the original curve, we're going down like that, okay? Now, over here, we've got positive f dash x values. That means we're going upwards. Over here, we've got f double dash x equal to 0. So that means we're going to create a point of inflection. Over here, we've got f dash x equal to 0. So we have to draw a stationary point along this line and then go down like that and end up at 4, 0. And that's how you do part 3. Okay, let's have a look at part 2. The graph of y equals f dash x is shown in the diagram below. Y equals f dash x passes through the origin. As x approaches infinity, and the positive and negative directions, f dash x is approaching 0, and f of x is approaching 0 as well. Alright, so first thing we analyze is that this gradient function passes through 0 here. Okay? So, if this is where f dash x equals to 0, that means there's going to be a stationary point along this green dotted line that I'm going to draw here, just so that you know. And then over at these particular cases, okay, what can you tell you about the tangents at these places? So the derivative of the derivative. Derivative of the first derivative is going to be f double dash x, right? So this is f double dash x. And we know that's equal to 0 over here and also over here. Okay? So, what does that actually mean? This means that at these points, negative 1 and 1, we're going to have points of inflections, because that's what they mean. Alright. Now, it says also here that to sketch the y equals f of x, given f of x greater than 0 for all values of x. So, if we're going to sketch f of x greater than 0, that means it has to be all above the x-axis. Okay? So how I would start to draw this curve, okay, I'll draw this in red, is that there will be a maximum here, like that. Okay. And I mean, we can actually analyze that at this point anyway, if we wanted to. So if I wanted to analyze that, I'll have x and f dash x, like that. In the center, I'll have 0, right is 0.1, negative 0.1. In the center, the gradient is obviously 0. To the left of it, it's a positive value, and to the right of it, it's a negative value. So we'll have a positive here and negative there, which means it's a maximum. Okay, that's why it proves this. Now, over along these slightly blue lines, which I'll draw here, okay, there is going to be a point of inflection. Okay, because we said that f double dash x equals 0. So, where does it go from here? Does it go like this? Does it go like this? Does it go like that? Well, it can't be going up or it can't be going down. Okay? Can't be going down because it says here f of x is greater than 0 all the time. Can't be going upwards also because there's no other part of the curve where it's equal to 0 like this point to create another stationary point. So we have a look over here. As x approaches positive and minus infinity, f dash x is approaching 0, and f dash x is approaching 0, which means the y value is approaching 0. So as we're drawing to the left like this, okay, I should draw that carefully. It's trying to approach the x-axis, which is y equals 0, or fx equals 0. It's trying to approach it as x approaches negative infinity. So we're going to have to put an asymptote right there, like that. Okay? Now we're going to do the same thing to the other side. So we're going to create a point of inflection and try to make it approach the x-axis, like how we do, like that, and then draw an asymptote like that. Okay? And I should also say that f dash x is approaching 0, which means that it's trying to be more and more horizontal or flat. All right. Question 3. Okay, this one's from Stratford Girls. Copy the diagram of y equals to f dash x below neatly onto your answer paper, then sketch y equals f of x below it, given that it passes through 0, 0. Ensure that both graphs are clear and neat. So, the first thing that I'll look at is where it is equal to 0. So over here, we can see f dash x equal to 0. Over here, it's also f dash x equal to 0. And over here as well, f dash x equal to 0. Now, I'm also going to point out where it would be equal to 0 for the double dash. Okay? So if we differentiate this curve one more time, which is already a first derivative, we're going to get the second derivative. And when we differentiate this curve one more time, we're looking at the gradients of the tangents. Okay, so specifically, I'm not going to look at the tangents that are flat, like that, and horizontal. Okay, so at this point, at these 3 points, okay, I'm going to label over here, f double dash x equal to 0. Okay, over here, f double dash x equal to 0. And also, at the same point that we had f dash x equal to 0, we have a second derivative equal to 0. Okay, now I'm going to point out what this means. Okay, so first of all, this means that on the original curve, f of x, we have a stationary point. But this one here tells me there's a point of inflection. Together, these two mean there is a horizontal point of inflection at that point. Okay? Whereas all the rest of these are just standard horizontal point inflections. Now, it passes through 0, 0 from the information. So I'm going to put 0, 0 here. Now let's have a look at the stationary points that we have to draw here. Okay? So I'm going to draw some dotted lines whenever there's some stationary points along those dotted lines that need to occur. Okay, you can draw them in an exam and then rub that out if you're drawing it in pencil. So that would be here and over here. Okay. All right. So how should I draw this curve? Well, first of all, this gradient here is negative, which means when I start drawing, it's going to slope downwards, okay? It's going to go down because my gradient here is all negative, okay? So if you think about it, if I go down like that, okay, and then there's a stationary point here, that means it can only go up like this, okay? And that's also indicated by that positive gradient here. That means I have to go up. So my beginning of the curve looks like this. Right? Okay. Then what I'm going to do is that I will have a point of inflection right here, which it looks like it is going to be. So it's going to go from concave up to concave down. And as soon as it reaches this dotted blue line, well, we see that f dash x is equal to 0, which means that there is a stationary point. So we're going to draw something like looks like this. Okay? We're going to hit that blue line, make a stationary point, and then along this green line, which I'm going to draw here, okay, there is a point of inflection indicated by the second derivative being equal to 0. Okay? Which means that it's going to go down like this, right? But it's going to create a point of inflection right now, okay? And from -1 to 3, all of these gradients are negative, which means I'm sloping down. So I'm going to create a point of inflection here, slope down. But over here, I've got a horizontal point inflection. Okay? So if I have a horizontal point inflection, and I'll make that really obvious, let me just draw that again. Okay? This part, okay, must be really horizontal, must be really flat, okay, because f dash x equals 0, and I'm also going to create a horizontal point inflection like this, all right, just so that if I was to draw a horizontal line right there, okay, none of that line should be up or below that horizontal line. Okay, what I mean by that is that you shouldn't be looking like this. Okay, should look like this, rather. Okay, I'll exaggerate it by saying, oh, it shouldn't look like this. Okay, so there's nothing on the top and the bottom like that. Okay, and also because this part has negative gradient, I have to slope down, and also this part has negative gradient as well, which means I still have to go downwards for my function. Okay, and that's how you draw f of x given f dash x.